The next section of the book deals with formulas and percent. So in this one, we're going to review basic mathematical formulas, percentages, and kind of how they all play back into equations. So the only difference between an equation and a formula is something that stands for something real, either a geometric relationship, a chemistry equation, physics, something basically that is designed to calculate a real relationship, where the letters typically will stand for a real quantity, something. Well, let's just look at some examples. In the packet, there's quite a few random formulas here. And as a quick review, I challenge you to remember what are all these formulas stand for. And to me, this is the most important aspect of dealing with formulas is, can I remember what is this for? Because if I don't remember what it's for, it's not very helpful for me. But for example, area is equal to length times width. This is the formula for the area of a rectangle. Or perimeter of a rectangle is twice times the length plus twice times the width. Area is equal to 1/2 base times height. Has to do with triangle. A squared plus b squared equals c squared is a formula you probably recognize, the Pythagorean theorem, which has to do with specifically right triangles. So all these we'd refer to as formulas in geometry, and they can help us solve properties of shapes or real objects. And those formulas are pretty nice because you can usually just Google them if you're trying to do something, and you can use them to figure out properties of the relationship. And other formulas related to not necessarily geometry, like for example, interest is equal to principal times rate times time, is a formula for very, very basic finance, where if I know how much money I've invested and I know the interest rate and the time allowed for growth, well, this is what is called simple interest. It'll give you how much growth, how much money you're going to gain in your account. Or distance equal rate times time. Circumference of a circle is equal to twice times pi times r, and the area is pi r squared. Anyways, if you know a formula and what it's used for, you can always use it to solve something. Like, for example, say we wanted to know what's the circumference of a circle who has a radius of 160 feet. And remember, the circumference of a circle has to do with the distance, or it's just a fancy word for perimeter. How long is it around the object? So if you can imagine this is a big field that's in a circular shape, and you were to walk from the center of the field to the outside, and that was a distance of 160 feet. If you wanted to know how long would it take me to walk all around it, or not how long, but what's the length of distance to walk all the way around the outside, that would be what the circumference means. And if you know the formula, circumference is equal to twice times pi times the radius, that will help allow you to figure out the property that you're trying to know. And formulas there's always a reason formulas are true as well, which is something that sometimes we might get into this, but sometimes it's just something that you can look up or have memorized. But in this case, the circumference is always equal to 2 times pi times r. And so in this case, another thing is sometimes we use symbols in formulas which are variables, or they're letters, but they're not actually variables, they're constants. So there's a difference between some letters and other letters. Some letters are implied to be unknowns, like r, radius, or x, or p, perimeter. It just depends. Sometimes we use other letters. Oftentimes we use Greek letters to stand for constant values, like pi, which is a constant you probably remember is approximately 3.14. But pi is a very, very, very complicated number, too complicated to get into right now. But it's a very difficult number that humans have spent many hundreds of years, or maybe even thousands of years, trying to understand better. But regardless, we often just use a rough approximation to pi being 3.14. And what's nice about those in constant values like that in formulas is it's not something that's changing. It's not a variable. It's just always the same. Whereas r, it depends on the radius of the circle, right? If this were smaller, the circumference would be smaller. If it's larger, it's larger. And in this case, we know the circumference is 160 feet. And a lot of times formulas have implied units. Like notice that 2 had no units. It's just a multiplier. Pi, no units. But this was in feet. The circumference is going to retain the same units, feet, as our original one. Whereas sometimes formulas will square the units, or change the units, which we often refer to as dimensional analysis, which is a very important thing in physics, chemistry, etc. But in this case, we're just multiplying everything together, and we can approximate 2 times. And another thing is your calculator actually has pi, a much more accurate approximation to pi within it, which if you hit second, the caret sign, which is the exponent button, you can access pi right there. Times 160. And that would give me the approximate circumference. Also, another thing is when we're using approximated values, I will often use a different symbol instead of the equal symbol. Equal symbol always implies exactness in the answer, whereas 3.14 is not the exact value of pi. Pi, it's technically an infinitely long decimal, and it's impossible to be exact. So I'm just going to switch it, which is the approximate symbol instead. So it's approximately 1,005 feet circumference. And if you're wondering, well, how should I round or whatever, it doesn't really matter. It depends on the context, but you can typically round to 3 or 4 significant digits. Or, it doesn't really matter unless, but it does matter in the online homework because it will often specify round to the nearest 10th, or round to the nearest 100th. So just read the details and make sure you're rounding to where it says to, because it might mark you wrong if you say you were to do 1005.3097 or 6. That's more accurate, but the computer doesn't necessarily, you follow the instructions, the computer might get confused. But also you can actually leave your answer exact. If you're wondering how do I actually express this as an exact answer, well, the only way to actually do that is to leave pi where it is. And basically just leave it as, well, c is equal to 2 times pi times 160. And, well, I know what 2 times 160 is. 2 times 160 is just 320. So I could just leave it as 320 times pi, and that's again in feet. And this would be an exact answer. And there is no other way to be exact with pi because it is just such a weird number, and our entire number system does not work very well with circular measurements. And there's a lot of other geometric objects that have similar problems in the decimal system. Anyways, I'm not sure why I'm getting into that in this video. But going back to formulas, the last thing that's important about formulas, this would be an example of using a formula to solve something. Sometimes you can solve a formula for a different variable. So most formulas are solved for a particular variable for a particular reason. And when we say a formula is solved, so like for example, we would say that this formula up here we often refer to it as the circumference formula because it's solved for c, the circumference of the circle. But you could take the formula and solve for r and solve it for the radius. And that formula would have typically a different purpose. And you would usually call it something different. And how you do that is actually the same way you solve a basic linear equation as we were doing in section 1, by basically adding or subtracting or multiplying or dividing from both sides in order to reorganize where things are at. So like, say for example, in the equation d is equal to rt, sorry, my dog's distracting me because I can see him licking himself back there. Say hi to Winston, everybody. He's right there. Basically, what solving for a variable, like for example, this formula is called the distance formula. Distance is equal to rate times time. Well, technically this is average only. This formula doesn't always make sense, but when you're talking about averages, it works. But we'd say it's solved for the distance because distance is by itself. But let's say we wanted to solve it for r instead. Basically, all that means is we want r is equal to law, but we want to maintain the same relationship because the implication is that this is a true formula. It's like an identity. It's not an identity. It's a formula because it's applied to a real life relationship, which is just true because it is. But like for example, if I'm driving a car 10 miles an hour for 2 hours, I'm gonna have gone 20 miles because my rate is 10 miles per hour. My time is 2 hours. If I'm doing 10 miles every hour, add those up, 10 times 2 is 20. But basically you can undo or change the way that that formula is presented, because basically it's saying d is r times t. Well, if I wanted to get r by itself, I could just divide both sides by t, because it's like the same strategy, right? If I want to get this by itself, well, how do I undo multiplication? I undo multiplication by division. If I divide both sides by t, t will cancel, and that will leave me with r all by itself. R is equal to distance divided by time. And this would be, technically it's the same formula, it's just solved for a new variable, and that it could help me solve something else. So say I was driving my car, and I knew the total distance I drove was 200 miles. And I could tell that by looking at my odometer, and seeing how much has changed. And let's say it took me 2 hours to do that, which I could tell by reading my clock, right? I could figure out, well, what was my speed average for that trip, 200 divided by 2, and now it would be 100. And again, this would be in miles per hour, mph, or, which is now a rate. It's changed from a unit of distance and time into a singular combined unit, r, which that's what r, means is the rate of speed. Which is 100 miles per hour, so I probably should slow down. But at the end of the day, the formula still works. It still makes sense, and it gives me a real relationship. And you could solve for time as well. Time is equal to distance divided by rate. And anyways, each of those formulas has a different use and could be used to solve a different type of problem dependent on the information you're given.